recording and share my screen one more time for fun.
Do you want to delete that? I made a little.
I'm sorry.
You was previously recording. You got a cousin over here.
What's that?
I said you got a cousin over here. Sounds just like you.
A cousin. All right. Seems like we're all ready to go, and it should be working. And yeah, it looks like it is. Well, let's see. Okay. All right. So a few things. First, the tests. I graded the tests, and I wanted to be able to get them back to you. And there are a few things about the tests. Some people did really well, and some people didn't do that well. And what I wanted to do is to actually go through the test and show how to maybe approach these problems better. Since you did have the resource of having the computer, it seemed like there was some, I don't know, it seemed like some people didn't understand the questions, and it would be helpful to do that. And so I think it would be best to do that next week, because next week I'll be down at the Golf Park campus. And so I wanted to say all that before I posted the grades. So to be clear, we're going to go over the test, talk about how to get the right answers, so that on the final, you'll maybe have a better idea how to do that. And in addition to that, I wanted to give those people the opportunity that may have done poorly on the test to have the final grade weighted a bit stronger than it was listed on the syllabus. So that'll be the way. I gave everybody an opportunity to kind of resubmit the take-home portion of the midterm. So this will be kind of a way to correct the second part. I mean the written portion, the in-class portion of the midterm. So there still seems to be some confusion, not quite understanding variables and loops and functions. And so I think that perhaps as we go through that next week when I'm down there, to see what it is, maybe there's a few questions where you could say, well, maybe if you asked the question in a slightly different way, it would have been more clear or something. But anyway, we'll do that next week. After class today, I'll post the grades as they stand right now. But I still think that there's room for people to pass the class if they understand those concepts going forward and do better on the final. And so that's what I wanted to say there. I didn't get them graded as quickly as I wanted to, so I haven't sent them back down yet, but I'll send them down. And actually, I can get access to one of those things. I may try to email them down too, but I'll also bring everything. Doesn't make a whole lot of sense to send them down. I'll try to email them down. I think that's probably the better solution. I'll email them down, post them on Canvas, or physically email them, and then I will bring the hard copies down that we can talk about. And Jordan, maybe you and I can also talk for some period of time about the test separately, because you're up here, and Ben as well, but Ben's not here today. He's attending from home. All right, so that's about the test, and obviously I'm not gonna like I'll post the grades. I won't like I'm not gonna tell everybody on the IVN how they did on the test, but okay, so Elvis asked a question related to last week's assignment, and it said add up all each of these data sets and save the output. Okay. So is that what the question you were asking about, Elvis? Oh, he stepped out.
Yes.
Oh, okay. Well, probably won't be gone too long. Well, it's on video, so it'll be recorded. Anybody else have that issue with the test? How far did we get in working on that project or working on that assignment? Let's see. I would have put that in the course, so that would have been M8, and then oh yeah, this is the one where I basically said, yeah, you need to kind of combine example 1 with example 2. So this is example 1 was taking just one of the records in that one of the layers in that directory, and performing the operation that has to be done on that. And then this was one where we just did that. Okay, so what we could do here is kind of go ahead, mash these two up like I said last week. So all right, Control C. So this is doing the Euclidean distance part, calculating it, getting the conditional. So yeah, one of the issues that seemed to occur on the test was this concept of what's happening inside of a loop. So last week we talked a little bit about this loop right here. So we have a value that's changing each time through the loop. Actually, before we copy this all in, oh here, I'll just comment this out. Format, comment out region. All right. So let's just run this the way it currently stands. I saved over the example 2. I shouldn't have done that. Oh, well, that's not too bad. Here, let me, that's fine. I'm going to file save as, call this example 3, 1 week later. All right, yeah, Elvis. So we're going through this. So this script, the way it's written right here, returns a list of all of the. Sorry, it iterates through a list of everything that starts with risk star, and so we've got a layer, and layer is what's the data type of layer? Well, it represents a raster, but the actual data type for the variable layer is not a raster, right? What is it? It does represent the path, and actually it doesn't represent a path to a raster. It represents the path to a shapefile, right? Like if I was to print out print layer each time through. Undo that. So each time through I print I print out the value of layer. This is what I get. Okay, and that is a shapefile. But if I also print the type of layer, what am I going to get?
Type of layer.
Yeah. This is a function that returns the type of the variable that's passed into it.
So is it like a numerical value? Is that what you're talking about?
Yeah, well, it's not a numerical value, but that is a type.
So it's not a numerical value. It's a class string.
Yeah, it's a string.
I thought about the thing. I said, no, you can't do that. Okay.
Yep. So layer is a string, and that string we know because we used this function, it passed back a list of every feature class in a particular folder. ArcGIS would call it a database or a data set, but that can be a folder. It can be an enterprise geodatabase, or it can be a file geodatabase. Okay, but we're asking everything that's inside of this workspace right here that starts with risk star and has a feature class. We want to get a list of it. This is a list. And so when we run this for statement, we're saying for each item in this list, we decided to label the item layer because we know that they're layers. Okay. But in reality, it's just a bunch of strings. See, the first string is this one, the second string is this one. And so I suggested, to complete this lab, what you could do is create another variable that was called outLayer that just changed the extension from .shp to .tif.
Right.
At this point, outLayer is still, what's the data type of outLayer?
Outlayer is going to still be a string.
Yes. And we know layer is a string because we used a string function, replace, to change the extension from .shp to .tif. So this is where we get to the next part, which would be to do the operation that we want to do.
Right.
So if I want to run it on every single shapefile, I can change this to be layer. Okay. So what it will do is it'll find the Euclidean distance from the items in layer. Okay. And then it'll use the cell size of 50. I already have the cell size here 50, so that's actually redundant. So I'm going to remove it.
Right.
What is this parameter? Does anybody remember from last week? I don't actually remember. The second parameter? Euclidean distance. It might be. Euclidean distance arc pi.sa. Let's look and see what it is.
Because I can get any numerical numbers from anything.
Okay, it's the maximum distance, and we don't specify one, so we could also eliminate that.
Oh.
If we wanted to. It's not going to hurt anything to have that there, but I'm just saying if we're feeding it the default value, we don't have to feed it unless it says it's not optional. But sorry, I said maximum distance is optional, so we don't actually have to feed it that. Okay. All right, so we're feeding it just the layer. The path to that layer, effectively, is what we're doing. It's still a string at this point. All right, but what does it return? What is out uc distance now?
Comes up with a numerical number now. If you done with Euclidean, when Euclidean come up with a number.
Number
value.
Well, yeah, it's it's a raster where every value represents the distance away from the elements in the shapefile that you gave it. So the distance raster identifies for each cell the Euclidean distance to the closest source cell or set of source cells. So that's what this is a raster, and it represents that. Okay. So now that it's a raster, we can perform just math operations on it. Okay, we kind of went over this last week, but yeah, we can get that. Finally, we're going to end up with a raster that's going to be called outcon. And one of the methods that a raster has is the ability to save it in a particular location. And so what we could do is, instead of saving it to this location, we could save it to this location. Because what is outlayer? What's the data type of outlayer?
Outlayer is going to be that TIFF file.
It's going to be a TIFF file, right? But is it actually in a TIFF file that exists?
No, it doesn't exist. But what it's going to do is it's going to take the current TIFF, current shape file and make it a shift file once it runs through.
It basically just changes the extension, but yes, it's going to now save that TIFF file out to that location. So it'll have the exact same name as the input data set, with the exception that it'll be .tif instead of .shp.
Well, this one made my problem is because when I ran that in the loop, it came back with an error because the output name kept staying the same. So I just went around it and just changed the outlayer to a number.
But the outlayer won't be the same. It's going to be, watch when I run this. And I'm going to bring this up while I do it. So this is in M8, ctemp M8. Ctemp M8 and tidyxt and part data. See, right now I have a few TIFFs because I ran it before, but I should probably just get rid of those.
So you say that it runs through and just put them all in place at one click?
Yeah. So see how right now there's a risk, ag, small scale, risk, ag, sugarcane, all those, right? But there's, when I run this one, it might be easier to see this actually in ArcGIS Pro. You'll be able, because it'll condense these DBFs and PRJs. Those are all really the same file. So let's open up this from last week.
I did them individually. I just changed the condition statement 1, 2, 3, and then I went back there and changed all their names to the name of the rich file. And I've done it your way. It's like doing an iteration. It's just going to burn through all of them.
Yep.
You just put the right thing in there.
Yeah, that was the point. Okay, folders, M8. Let's connect to a new folder. Desktop. No, C temp. M8 tidyxt and park data. That's what I want to connect to. All right, so I've connected to that folder. So now, as it runs through, we should be able to see. We've got all these temporary files that we created last week, so I'm going to get rid of those because those are just things that we were doing earlier. Might not. Okay, it's not letting me delete those. That's fine. Well, it's not letting me delete all of them because some of them are still being used. Yeah, here, let's just remove. Okay. Now I can, whoops. Okay. I think that one's still there. Okay. One more, and then we'll be able to delete.
I got the same thing you got, I just did it manually, I wish I could have known that little piece you threw in there, 'cause that would have helped.
Uh-huh. Not sure why it's not letting me delete just that one, but let's just pretend it's not there, and we'll run. We're going to run this the way it is. So I'm going to run it, and what's happening is that as I run through this, I'm doing these commands, and I'm saving the output layer. Now, if I go to ArcGIS Pro and I refresh, I get a TIFF file for each of the other ones that, for each of the risk layers, and that TIFF file should show me what I want, like related to that. So this is the distance from small scale agriculture file. This is the sugarcane file. Let's move this over. And this is just the watershed boundary area, because that's all I cared about. That's the bauxite. This is the quarries. The roads be kind of cool. And then the risk towns. And then the urban areas. Okay. So that worked the way I wanted it to, writing it that way. So your question is, how now do I add all these together? Well, if I did that in just raster calculator, I'm just going to show you what I'm talking about first, because maybe that's your question. If I did that in raster calculator, I'm saying something like risk urban areas plus risk towns plus risk roads plus quarries plus bauxite mines. 1, 2, 3, 4, 5 plus sugarcane plus small scale agriculture. I think that's all of them. And then I'm going to have an output raster. I'm going to run this guy. Okay, so this is the output that I want, is the addition of all of the individual rasters. So that's the final product. Was that your question, or?
I didn't know I thought you were supposed to come up with a number, but what you're doing is this, making a complete picture of all of the risk property into one map. So there's a composite of all the risk factors into the map, correct?
Right. Yeah, that's the composite of all the risk factors on the map. And then if I wanted to make the background value.
Isn't that background null value?
Well, in this case, the background value is the background is 0. So if I want to change that so that now it's basically just clip to the watershed like that. Oh, I turned off that one by accident. So yeah, that's the output. That's what it should look like. Now you don't have to actually turn that in. It's the code. But how do we code this last step? In other words, how do we code the result there? Okay. So I ran it here. So here we've got the help on this, and the thing about raster calculator expressions is that a raster calculator expression could just be entered directly into Python, and it will understand that those data sets are what we want. So here, I'll show you just adding a couple of them, right? So so outside the loop here, I could say final Master. I'm sorry, go ahead. Did you have a
You
question?
recording all this?
Yeah, this is all being recorded.
All right, thanks.
Yep. So I could say layer. No, layer doesn't equal anything right here. Why is that? Like layer doesn't exist anymore. Well, it might, but it's the very last one. I forget how Python treats it, but in a loop, now it should either equal the last one or it should be considered a local variable in the loop. But I could go like this: data list 0 dot place. I'll just do this. There are a few different ways to do this, but this is what I'm doing here. So I'm taking the final, I'm making a final raster. This one should be 1. That is where I take data set 0 and I get the dot .tiff. I get it to say dot .tiff instead of dot .shape, and then I add it to data list 1 where I have SHP and not TIFF. Okay. I mean, sorry, TIFF and not SHP. Okay. So now, if I run this, I'm going to get a problem because ArcGIS is open, I think. Let me try it though. I also didn't save out final raster, did I? Something like that. Yeah, I'm unable to delete. So I'll just save this and close it. And now I'll run this guy. And I should now have an output called final.tiff. That's what I called it. Oh, I have to open up ArcGIS Pro again. I think it would have worked to just take those out of the table of contents.
So it's going to add up all those rasters and create the same map that you just created with ArcGIS?
Well, it would if I had coded it that way. So,
okay.
So now I have a final.tiff, but the final.tiff is just the first item in the list plus the second item in the list. It's not every single one. So I would have to change this so that it was every single one. And I don't know, did we go through the, I know I had it on the list of things to talk about, but did we go through the eval statement?
No.
I think the easiest way to do this is the eval statement. So let me go to the interpreter for a second. All right, so the eval function. Eval is a function that will run Python code, but you give it to it as a string. So it takes a string of Python code. So if I say A plus B here inside of Python, oh, well, that won't work. If I say eval 4 plus 5, what's the data type of this?
That's going to be a string.
Right. But eval takes a string, and it's short for evaluate. It evaluates it as Python and returns the result. So if I run this, it returns 9. just as if I had done 4 plus 5. Or, sorry, 4 plus 5. So eval takes a string and returns the evaluated expression in that string.
So what you're saying is it can turn the name of those risk towns and do the multiplication as if it was math, because it's doing the same thing, but risk plus this plus this, and it'll come back with a number.
Right, because see here, right here, I had to give it these two values. So the secret is to construct a big string that says this using code, and then pass that into the final raster using the eval statement. Here, I'll show it to you this time because we're going to practice this again this week. So we'll just do this as a demo, and then you'll basically have the answer for this week. But we're going to do it again. We're going to do it again this week, so you'll be able to practice using it this week. All right.
You always have to initialize the data list with 0 always, so that you get your numbers correct. You always have to be initialized with 0.
Well, I need every single item in the data list. In other words, what I really need, this is going to look complicated, but it's not. So I forgot how many items there were. Let's look. 1, 2, 3, 4, 5, 6, 7. There's 7 items. And so what we really need is 0 plus 1 plus 2 plus, plus 3.
All the way to 7.
All the way to 7. Yeah, exactly. And there's no way to programmatically build that without what I'm going to show here in a second. Because what I actually want is all this. I could make this a little bit better by if I went like this and said outputs. I'll call it output list and make it empty. I could save output list dot append, and then I could put outlayer in it. I'm going to comment this out for now, and I'll have to comment this out too. So now output list, I'm going to print it. What's output list going to have in it?
Output's going to have all those register files in it.
Yeah, it's going to have all those strings that represent output files in it. Exactly. So I'm going to run it, show that. Do I still, hopefully I don't have, I do still have, nope. I guess I do still have it. All I need to do is remove these temporary files, because it's not temporary, but it's gonna try to write over those, and because they're open already, I can close this. Okay. So I'm gonna run this guy and show that what I get is I get a list of all those. See, I've got a list. That means it's a list, and I have all of the TIFF files listed in there. Okay. So I can modify this now. I don't need to do this stuff. I could just say output list 0, and then output list 1, and so on. Like I can actually get rid of all these other guys.
So you're doing it because you already defined the list above that?
Right. Yeah, I defined I created the list above that, and so now I just did that for simplicity's purposes so that this will be a little bit easier to read. And we would just build this out, 0, 1, 2, 3, 4, 5. But we don't want to have to do that. So one thing that we could do is, instead of this line here, we could use the eval statement. So watch this. We say final raster equals eval, and we could, here, this will make it even easier. We'll just say, inside here, we'll say raster plus outlayer plus. So what's this going to create?
Okay, yes, outlayer. That's going to create the this. That's going to take whatever that list and append it to the.
Yeah, it's going to create a string, and the string is going to look like this, except for it's going to have the path inside, which is actually what we need. So now we could just say output list dot we need to join the list. Join list Python. Join function in Python.
So you're going to
String name. Okay.
join all files to make one now.
Yep. Dot join output list. Whoops. Output list. Okay. So it's going to eval this statement. I'm going to print this statement so that you can actually see what this statement looks like. Print. I'm going to print that statement so that we can see it. And then now we can save this. And actually, I'll put this before it. And I'm also I'm gonna print some white space here, just so that we have some white space in front and back of that. Okay. So now we're gonna run this guy. Oh, it's not gonna run no unless I delete. Oh, I deleted it. Risk small scale. Oh. Outlayer. Let's comment out these two for a second and see what this looks like, because it's already there, isn't it? Okay. So yeah, we don't need to comment that out. So look, what it did was create a list that had all of these things: risk underscore ag small scale dot tiff, and then risk underscore ag sugarcane dot tiff. It had all of the layers. And so when I did this line, what it did was it combined all of those layers and put a plus sign in between. The only problem is there's actually one more problem. What's wrong with this as an eval statement? Like, if I was to put that in Python code, why wouldn't that work? It's actually a similar test question, similar to a test question, one of the written test questions.
Well, you're only adding together a picture. Okay, around two.
So, is this the name of a variable or is it a literal thing? Like,
It's a literal thing.
right, it's a literal thing, so I want to tell it that that's a literal thing, that is a variable, and so I need to mark it with its data type. So what should its data type be?
The data type should be a
It's not a variable. What's that?
So it used to be a shape file, but you changed it.
Right. Remember that it's an entity that represents it represents a location on disk.
So it's a string.
And so it's a string, right? Well, Python is not going to interpret this as a string. It's going to interpret it as a variable unless I put quotes around it.
Right.
And so what I need to do is add quotes around it. So now I'm going to run this one more time. I actually have to run it two more times now, but you could see once it runs here that now we have quotes around it. So now Python, when it interprets this entire line, I could just put this into the interpreter. That's the same effect as the eval statement, and press enter. Now it's going to run it. And this is where it says it saved it. Okay. So now let's try to uncomment out these two lines of code, and it should work.
So the map begins.
So what I did was I built a line of Python code. That's what this is. It's a line of Python code that I built. In my code, I built a line of Python code, and then I used eval to execute that line of code. And so now I have the result, and that is right here. Go back to map 2, and I can add final.tiff. And if I symbolize final.tiff in the same, see the high is the same. This is exactly the same as doing it the way I did it earlier in just using the GUI, but now I have the exact same display background value is 0. Now I have the exact same layer. Final.tiff is the same as risk_urban A. So I'll put this back up there on GitHub. And so what I'll say here, I could put a comment here and say, build a list of each raster data set to build the final command to run in eval. And
So eval simplifies the of those
well, not only does it simplify it, but making the list simplifies it. But eval allows us to do this. Otherwise, there wouldn't really be a way to do it programmatically, because we need to say A plus B plus C plus D plus E, and we don't know how many they're going to be. You know, this time we know there's going to be 7, but what if there was 8 next time? You know, that's the power of programming, is to make the function general enough that you could run it in different places. So
you can say it joins the spatial location. It actually brings all the spatial locations together based on the map that you did, what otherwise would have been a regular string, but it took those spatial locations and knew where to put them at based on the when you wrote the statement.
yeah, well, what it did was it took a list of data sets and it said, I want to add up every item in this data set, regardless of how large it is. I want to add all those up. This is the way to do it. I want to take all the raster data sets in a list and add them together. This is the way to do that.
So when you say the word add, I was looking for numbers, but what you're doing is you're outputting a large raster of files that have been stitched together. So we said, hey, that's what I'm looking for, a number. What you were saying is that it takes rasters and stitch them together based on the fraction is actually doing that. So you made a picture based on that and you join them in the middle like you did. That's what I was trying to do.
Yeah. So what is a raster?
A raster is a location file. What is that?
Group of cells with values in them, aren't they?
Right. Exactly. It's a two-dimensional group of cells. You know, we got rows and columns of cells where every value represents a number. If I zoom in here, you know, I can see that this cell right here has a different value than this cell right here. So when I say add them all up, I'm saying add the value in this cell. I'm going to turn off the top layer here. I'm going to add it to this. I'm going to add it to this number, the exact same number, the number for the exact same location, and then add it to this number, and so on. That's what adding rasters up means.
Okay.
It's a local operation from last semester where I'm basically taking a bunch of rasters and adding them all up through the different layers.
So when you had over 100 shape files that you was trying to do, that would be tedious, wouldn't it?
It would.
But
I mean,
that's not the way you do it, correct?
right. I personally think that. I mean, you guys might not, you know, be to the point that this is the case, but I personally think that writing these, how many is it? These 29 lines of code would actually, there's a lot of breaks, so it's probably more like 15 lines of code. And once you take out the comments and the breaks, writing these 15 lines of code is faster than having done this for just these 7 data sets. Right? But you're right. Like you know, you have to practice and build up your logical skills and your programming skills for it to be faster. But it is faster to do it that way. And you could do things like, you know, what if I only wanted to do the first 3? Then I could just add a line in my code here and say, you know, data list is equal to data list, and say 0:3. And now when I run this, I'm only going to get the first 3 items. Or more, or something that might be more useful would be to adjust this. So if I had changed this to this, I'd be running it for all of the shape files in the directory. So now I'm running it for all the shape. Well, I gotta change the output. I'll just call that final 2. There we go.
So it doesn't matter how many you have, it's going to just run whatever is there.
Yeah. I gotta get rid of all these data sets. Just not have them up in my project. That's the problem. So yeah, now if I run this, it's going to get every single. Watch what happens is it gets every single shapefile in that. So it gets not just the ones that start with risks, but the ones that start with targets and the watersheds. So now the final output's going to look different. I called it final. I renamed it. Final 2.
And now, what did it do? It created every item that was in that Tisdale Center.
Yeah, so just by changing this line right here and saying that I wanted everything instead of just the things that started with risk. That's what I did originally.
Right.
What happened was that when it ran through, it did it on all of the ones that started with risk, all 7 of them, and it did it on all the ones that started with target. It basically did it on all of them.
And when you would have to do that or couldn't do that because it saved you time on doing all the other stuff, is there a reason why you would put it there at the wow?
Well, for this particular example, it doesn't make a lot of sense because the reason that we originally did this was to calculate the risk factors involved, not the in this case, the risks represent usually human activities that are potentially a problem for the things that we're trying to protect. And the things we're trying to protect, we call targets. And so if we wanted to make an overall risk surface, which is what we were trying to do, then our risk surface should be a sum of only the risks.
Right.
So basically, this is a map of those areas that have the highest risk, the highest human activity. And if we're trying to set aside areas for conservation, we want areas that are lower. And so the purpose of making this particular map was to identify those areas with the least human activity going on.
Correct. And plus, you don't want a composite list of everything because once you come out with that final tip, you can't individually take any particular thing off to show it. It's going to come out as that final composite.
Well, it's always good to have a final result, but you're right. It might be good in some situations to understand what factors are causing, like, here the highest values are right here. Well, what factors are causing those high values? We have to look at the individual maps to see that. So yeah, if we were gonna, like, let's say publish this in a journal, or even talk about it online, we might want to have the overall map and then have each of the individual maps to go with that. And that's what one of the things that we'll actually talk about in the last few weeks is using interactive Python as a way to display the results. And so you can display map results, or you could also display tabular results. So we'll circle back to interactive Python here coming up and display those results. And I could even, maybe that'll be one of the examples that I'll do is showing these data on using interactive Python as a result. Okay. So yeah, go ahead.
What to do can be duplicated just writing Python code as ArcGIS. That's one way of checking to see if this stuff is the same, is by trying to duplicate the code using Python, see if you come up with the same map.
Yeah, sure. That's valid. Use Python to see if well, I mean, lots of times when I'm running something, I try running it using the toolbox, and then I'll understand what I'm doing, and then I write Python code to automate a task like this, which was to take everything in a directory and change it or update it.
Could you do something like that in model building?
Yeah, you could do it in Model Builder. That's true. Model Builder also has a learning curve associated with it as well, though. So
Okay,
yeah, I mean, you could, I think you've even asked this before in class, but yeah, in Model Builder, there is the ability to put in iterators, which are loops. So you could loop all these together. Now I'd have to go read the model builder help, but what we did today with the eval statement, I think would be hard to replicate in model builder, but maybe there is a way to do that, because basically what you're doing is you want to add them all together, and then, but what you could do it with a precondition. So you could do, this is the way you could do it in model builder. You could have one iterator that went through all of the feature classes in a folder, added them all together, and then output the results into a different folder. And then you could have another iterator that wouldn't run until the first iterator was done. And what it would do is take all of the files in, all of the raster files in a directory and add them all together. So you could do it that way.
Just understood me a bit right. It takes a lot of time.
Yeah. I mean, either way, you have to think logically. You have to come up with a recipe to do it, and just that recipe is another word for an algorithm. You have to come up with a method to solve your problem. That's always the first step. You think, how am I going to solve this problem? And you need to come up with a methodical way to solve the problem. I'm going to run this tool, this tool, this tool. I have to have this logic. You have to boil it down. Okay? If this happens inside the code, then I need to do this. If this happens inside the code, I need to do that. And then once you have everything boiled down to methodical steps and logical operations, then you can code it or put it in model builder. But either way, in my opinion, the harder part is finding out what the way to solve the problem. Because once you do that, you can use the help to figure out how to put it into code or how to put it into model builder. It might get a little frustrating at times, but to me, it's not nearly as frustrating as the not frustrating, but it's not nearly as hard of a problem if you just figure out how to do it.
But doesn't model builder use the same terminology? As long as everything in the data set you're looking for, doesn't model builder use the same terminology that you would normally do if you was calling up on a geoprocessing function? It's there, it's just you gotta understand where to put those items and join them together to make it a
right. Yeah, model builder. Model builder has those. Runs tools exactly, but it also has these other things that are basically make model builder like programming. So it's got the logical workflow. It's got the iterators, so that you can write. You could duplicate what we did in model builder, but only with these additional tools.
which you have to know. Yeah, that's a lot of stuff.
Yep.
Too much for this man, right, Dr. Ray?
What's that?
Too much for this man. There's a lot of different stuff.
Well, this class isn't a class about model builder. And personally, like I said before, I find it much easier to operate in Python than in the model builder world. But maybe if that's your preference to use model builder, then you don't need a university class on how to use model builder. There's plenty of help out there.
Well, Python is pretty, I see Python, if you don't want to control, it helps you get it. Python is pretty cool, if you understand the logic of what you're saying.
Right, yep. That's true.
You operate off all that knowledge of the code, but we just kick it through it and hold on.
Yep. Yeah. I mean, as with anything, you gotta tackle it and it's a challenge. All right. So I'm gonna close this up. Actually, I'm not gonna close it up. I'm just gonna do a new project, new map. We're gonna call this M9. wonder if I should put this. That's fine. We'll just do it there. Okay. So what we're going to talk about today, as you remember, we spent 2 weeks on doing ArcGIS. Well, actually, we spent 3 weeks on doing running ArcGIS tools, and mostly that dealt with vector data at first. You know, the overlays and the buffers and that sort of thing. And then we moved on, spent 2 weeks on that, and then we moved on and we started talking about cursors. And then we spent 2 weeks on talking about cursors. The first week was just generally talking about using the cursor to loop through all the records in a vector data set and inspect them or update them. And then we spent the last week talking about reading the geometries from those, from that information. Now, in a raster data set, is there any geometry to read? Like, is there any, like, no, there's not. There's only what? You actually said this earlier, Ashley.
Cells.
There's only cells. And those cells, they only have an implicit geographic location. Every cell doesn't have an explicit geographic location. In other words, the cell does not store information about where it is in space. Okay, the only thing that stores information about where a raster cell is in space is the raster itself stores the corner. And it really doesn't matter which corner it stores, and there are different raster formats that store different corners. But ArcGIS is consistent in that the Python interface allows us to specify a corner and then build a raster doing that. All right, so rasters don't store that, but they still have a value or an attribute. So like vector data, a raster has an attribute associated with it, but it only has an attribute. Every raster data set has an attribute associated with every element, which the elements are cells, no geographic location. And so today we're going to talk about the way that ArcGIS has given us to inspect and update and change the individual elements of a raster. And the way that they've done this is that they have allowed us to turn any raster data set into an array. And they've also allowed us to take any array and turn it into a raster data set. So once we have the item as an array is just a sequence, okay, just like a list. And once we have that element as an array, we can go in and we can inspect individual elements. We can find an individual element and change it. We can actually run functions on individual elements or run functions on the entire array and then convert that into a raster data set. Okay? So it's the closest thing we have to a search cursor or an update cursor, a cursor for the raster GIS world. So that's what we're going to talk about today. Okay, so the first thing I'm going to do is, if you look at the data sets, if you look at the GitHub for today, so this is what I'm talking about. Like if you downloaded, close this. If you downloaded I'm now going on to M9. If you went on to M9 here and you downloaded, I have all the examples that I want to follow labeled as 2019 _example.py. I made the examples before class. I didn't modify this lecture a whole bunch from last time. So if I open up example 1, I will have I'll have some things to talk about here relating to example 1, rather than just type out the entire thing in front of you. All right. So what's going on here is that in order to access a raster, or in order to create a raster from an array, I have to make an array. Okay, and there's lots of different ways to make arrays. I am going to like comment this out and then run it and then uncomment it out so that we can build on it like we usually do. So format, comment out region. Okay, so I'm going to run just this part. So I don't really need the ArcPy stuff right now, but I'll need it later. Because right now I'm just doing NumPy stuff. And by the way, if you go to the help for NumPy, there's a whole, we've talked about this before. I think I've even linked it before. So NumPy, if you go to the numerical Python is what it stands for. If you go to the help, lots of times the help will actually put it in as import NumPy as NP. I don't know why they did that. Maybe because it's less keystrokes, but it's not that many less keystrokes. If you did that, if you said import NumPy as NP, then you'd have to change this to NP. Okay. All right, that's the only difference there. So it's basically relabeling the namespace NumPy to NP, just so that if you look at the help, it doesn't necessarily confuse you there. All right. So what's happening here is that I'm using a function called a NumPy function a function that's in the NumPy namespace called random, and it generates random integers that are between a certain value. Let's look at the help for this. They're between a certain value and of a certain size. So here's the help for that thing. So what this does is it generates a array that has a low value as the first parameter, a high value as the second parameter, and the size as the third value. So what happens is that we're going to get a new array. I don't know if we've created an array yet in this class, but that's what we're going to do. And remember, it's going to look kind of like a list. It's an array though, and an array that is going to have numbers from 0 to 100, and it's going to have 25 elements. It's just a way to create a empty array. And I'm going to print that. Actually, I'm going to print right here. Well, first of all, I'm going to comment out this line and then run it. So here's my code so far, which is just the first basically 3 lines of code. So now I have this is the array that I just created. If I run it again, I'm going to get a different set of numbers, but they're still all going to be between 0 and 100. And in fact, computers actually have a kind of trouble creating random numbers. Because computers only follow people's directions. So the way that they actually create random numbers is that that they have random number tables out there that were actually generated from people, creating random numbers, drawing numbers out of a hat or something similar. And they build on that, and the random numbers that are generated, they take the time that it is, and they look at the random number table and start at that particular time. So if you have 2 computers and you ran the Python code at the exact same time, it would always generate the same random numbers, is what that implies. Anyway, that's not really the point. So for all intents and purposes, we've got 25 random numbers between 0 and 100 here. Okay, that's what we've created. Okay. Now I've talked about an array before, and I said it's kind of like a list. So we can actually get the individual items out of there. So if I went print my array 5, what am I going to get? Not the number. I don't care about what the number is going to be, but what does that mean? My array 5.
Sixth number.
The 6th number in the sequence. In this case, the sequence is an array. So here I'll go and look. So 0, 1, 2, 3, 4, 5, and I get 34. So that's just showing you that an array is simply a set of numbers, and that's a sequence. One of the things that's different about an array than a list is that every element has to be of the same data type. The array is a special structure where you can't mix data types. In a list, they can all be different data types. Okay. But not so in an array. One of the things that it shares, that it has in common with the list, is that it is mutable. Okay, so I could say my array 5 equals 0, and then print my array 5 again, and you'll see that when I run this, we're going to get values. It used to be 87, and we changed it to 0, and I should have actually printed the array again, but if I printed the array again, 87 would be 0 now. So it is mutable. We can change the values, all right? And we are going to do that here. Okay, another thing that I wanted to show you, notice I have this line of code commented out. For right now, I'm going to delete everything before the comment and run that again. And this time, I'll create an array that's the same size, but everything has the same value. So this is just another array creation routine where what I did was use the function numpy.ones. Numpy.ones is a function that creates an array where every element in the array has the value 1, right? So why did I get 5? Why did I get 5 here?
You did times 5?
Yes, because I did times 5. So I multiplied the ones by 5. So that's another thing that's another thing that you can do to arrays that you can't necessarily do to lists. Okay, this is called this ability is called broadcasting. You can basically feed it a formula, and it will apply that formula to every single element in the array. So you can add, subtract, multiply, divide. You can do any combination of those. And it will do that for every single item in the list. In the array. You can also take two arrays that are the same size and put them together. Okay, so let me go back here. So here I have my random array, and I could say my array 2 is equal to this. So now my array 2 is going to be that array that contains only values 5. So it's going to be a bunch of 5s, but they're the same size. I can then add my array, then add these two together. My array 1, or no, I didn't call it my array 1, I just called it my array. I spelled everything right. Plus my array 2. So what I've done is I've used the ability to broadcast to add two arrays together, and we'll see what I get. I'm going to change all these print statements so that I get my array 2 and my array 3, and I'm no longer going to change that element. So I'm going to print each of the arrays that I'm talking about here. So I'm going to run this guy, and now I have, whoops, I'm going to make this smaller so I can bring it up more north on the screen. All right, so I have the array that was created using the random function, and I have another array that was created using the ones function where I added 5, and then finally I added them together. So 35 plus 5 is 40. 32 plus 5 is 37, and so on. 89 plus 5 is 94. Okay. What do you think that little dot means? By the way, anybody want to guess?
Stop.
It's a good guess. The dot means that those are floating point numbers. So this array is floating point numbers. The second array, the 5s. The first array is integers. And so when I add them together, I get floating point numbers. Same as if I did, 35 plus 5, I get 40. But if I did 35 plus 5 with a dot, I get 40.0. I'm not sure why, when it's inside of an array, they don't put the full notation, because usually we would put 5.0, right? But the programmers of Python have chosen not to give us any significant digits that we don't need. But we still need to see the dot to understand that it's an array of type float rather than an array of type integer. Okay. But it is consistent in that in Python, when you add an integer to a float, you'll get a float. When you add an integer array to a float array, you'll get a float array. So that's consistent in that way. All right. Okay, so we've created that, and we printed it off. Okay, now let's look at this next line of code. I'm going to reset this to the way it looked before. Okay.
Did you say that it has an immutable value in the first array, like 0, 125? Are those immutable or just the last one?
Well, this is before the array is even created. The array doesn't exist at this point.
Okay.
This is a function to create an array. So my array is a brand new array that's created from this function. Once it's created, it's an array of numbers from 0 to 100. And an array, any array, is not immutable. Another way to say that is it's mutable. You can change the values in an array. Okay? Arrays are very efficient, though. They're much more efficient than lists. So in memory, they're all stored together, and kind of like the same way that a raster is stored on disk. It's just a bunch of numbers, and the only thing that the computer knows is that the array starts here in memory and ends here in memory. And so when you ask for an individual element, it just can quickly skip the other elements because it knows that all the elements are the exact same size. So it doesn't have to inspect each element when it does loops and things like that. So they're much more efficient to work with than lists are. And when you're working with a big set of numbers, they will work a lot faster. There's not a lot of overhead with an array. Of course, if you're, yeah, go ahead.
This can have strings in it, but we're talking about arrays. We always talk about numbers, correct?
They can have strings in them, but they all have to be of the same size.
Okay. Yeah. Same type of size.
Yeah. So they always have to set the same number of characters. Yep. Now, next week, once we start talking about record arrays, uh, there will be a few exceptions to that, but yeah. So numbers are extremely efficient. Numerical arrays are extremely efficient, and NumPy was actually created for dealing with numerical arrays, and it evolved to deal with all different types. But NumPy stands for numerical Python. I believe I pointed that out already. All right. Now, another thing that's different about arrays than lists is that we can reshape an array to be of a different dimension. Arrays can have dimensions. Okay. Lists can kind of replicate this ability, right? Like we could have a list of lists, right? A list that contains other lists. But this is different. This is an array, and on disk it's actually still the same thing. It's just that its dimensions help us to kind of organize the array in our head. And as geographers, we're usually going to deal with either 2 or 3-dimensional arrays. A 2-dimensional array is a raster, can be thought of as a raster. So here I'm going to create a 2-dimensional array from my original array by reshaping. I use the one of the properties of an array is its shape. So I can tell an array that it has a different shape and say that it's 5 by 5 rather than saying that it's 1 by 1. Or I'm sorry, 1 by 25. So I run that and I print it out. And now my array looks like this. I've got 5 rows of 5 elements, where it used to look like one row of 25 elements. By default, that's how it looks. So here, let me print it before and after the shape command. So here, this might make a little bit more sense. So here, the first line is the default array that was created that just has a bunch of numbers as 25 different elements. So how would I get the 25th element here? I could just say, my array bracket 25, or it would be 24, right? Because there's 0 would start. But how do I get 62 here in this array? I have to actually reference it by giving it both the row and the column information. So here I could say, I want to get my array, and I give it a bracket. Whoops. I use a bracket. And I say, if I do 0, 0, I'm going to get 32, the first element. See 32? But if I say my array 0, 1, 2, 3, 4. So if I say 4, 4, I'm going to get 62. And if I say I want my array 0, 1, 2, 2, 2, then I get, whoops, I need to spell it right. My array 2, 2. Then I get the one right in the middle, 28. But I could also get individual elements, other elements. 0 or 1, I'll do 1, 3. What will happen if I press enter there? 1, 3. What's that?
32.
32. Okay, I got 60. Why did I get 60? There are 2 60s there. Which 60 did I get? What would the index of this one be?
So you get 99.
It's in rows and columns, by the way.
Okay.
So what was 1, 3?
Is it going across 1 and going down 3?
It'd be 4 or 1.
Yeah, so this would be 4 1s. Rows and columns. So 1, 2, 0, 1, 2, 3, 4, and then over 1. So that would be 4 1. So this is the right one right here because it's going down 1 row and over 3. Rows and columns.
Okay, 1. Okay, I got you.
And then you still have to remember that the 0 is the first one, right?
Yes, you still have to remember the 0 is the first one. So 0, 1, and then 0, 1, 2, 3 to get to 60.
Okay, 0, 1. Okay.
Yep. And we can actually iterate through arrays just like we can iterate through lists for x comma y in my array and my array. I don't know if this is the proper syntax. X comma y. Let me see. Yeah, now I actually have an example that I wrote up, but I just forgot for a second. In Python array loop to two-dimensional. For row and A, for elements in. Yeah, it's still rows and columns, so this should work for doing each row. 5. Oh yeah. So this is going to print each. This printed each row in the array, and so if we want to do actually it might be useful to call these columns for item in column. Print item. No, because I didn't spell out the whole. This is just the name of a variable. Actually, these should be rows. Sorry, but they could be anything. But they represent a row in the array. I'm going to call it element. I think that's a better element. That's how you loop through every item. I need a colon, right? That's what I did wrong. So there's a for statement. So I'm going through every element in the array. So now I'm just going to get a printed list of every one, starting right here. 22, 11, 7, 44, 6. Then it loops to the next row and goes all the way down. 164 are the last two values there. So it's just going like this through the two-dimensional array. Okay. All right. So that's shape. That's what I'm doing there. Is reshaping the array to 5 by 5. The reason that I'm doing that, you'll see here in a second, is I'm building a new array to turn into a raster data set. So here is the code to do that. So the first thing that I need to do, well, this NumPy array to raster converts an array into a raster data set. Now, in order to do that, we need to give it a few things. So let's look at this function in the ArcGIS help. What? I don't know why it tried to make me log in before. Okay, so here is the function and the parameters that are necessary. So the first thing that we need to feed it is the array. The second thing that we need to feed it is the lower left corner, and that needs to be a point object. Okay. We created points before when we were building them to put into vector data sets. But here, remember, with the raster data set, we need to define a raster data set geographically. Where is it geographically? And the only thing that we need to feed it is one point that will define it. And so we need to give it that point. Then we need to give it the cell size, because that's the other thing that determines the geographic location. So if the first cell is located at 0, 0, let's say, at the lower left corner of the very first cell is 0, 0, the next cell over, where's its lowest left corner? The next cell over in the row, what's its coordinate? How do we know what its coordinate would be?
Would it be 0, 2?
Well, if the cell size was 2, it would be 0, 2, right? What if the cell size was 10? What would it be?
It would be,
The first, if it was 0, 2, the cell size has to be 2. So what if it's 0, 10? What does the cell size have to be?
10.
Yeah, exactly. So every single location is determined by the position of the corner, which doesn't always, it's not always 0, 0. It could be 155, 2, whatever. It could be all sorts of things. But whatever it is, the cell size determines the position of all of the other cells. Now, rasters can actually have cell sizes that are irregular. In other words, they can have a cell size of 5, 3, meaning that they're 5 units across and 3 units high. That doesn't happen very often, but it was more common. There were some satellites in the early days of satellite remote sensing that actually sampled the Earth at different intervals when they were going one direction versus when they did the overlap. So they had cell sizes that were different. But usually your cell size will be the same both in X and in Y. And so you need to feed it a cell size. The default value is 1. That's what you need to feed it. And that's why you need to feed it that. So that it can put the raster in the right location. So that's X and Y. You can optionally, go ahead.
The cell size is the second number, so if I say 0, 2, the cell size is 2. If I say 0, 10, the cell size is 10. Is that corner number the cell size? If you saying 0, 10, I said 10.
No. So here, let me, yeah, you're confusing two different things there, Elvis. Let me show you what I'm talking about here. Let's say that this area represents a raster cell. Raster data set. I'm just going to make the cells look roughly the same size. Those are roughly squares, right? So this will be our raster data set. Trying to make them border. Outside, inside. All right. I'm going to zoom in here a bit. All right. So this is I wish those were a little bit darker. Let's do. Okay. All right. So these are all the cells in our small raster. It's a small raster. Okay. Where does this raster exist in geographic space? No one knows. if I'm telling you I'm going to insert one column here just so that we're going to talk about this one. If I'm telling you that the corner of that raster is 0, 0, this corner right here is 0, 0. So what is the corner of this raster? This corner is 0, 0. What's the corner of this? Sorry, of this cell. What's the corner of that cell? If that's 0, 0, what's the corner of that cell? Yeah, because 0 is x. So it'd be 0, comma. What I'm trying to say is it's 0, comma x. X is the cell size. So the corner of this cell right here is 0, comma the cell size. The corner of this cell is 0, comma 2x. The corner of this cell right here. Maybe I should move these over actually. So the corner of this cell right here is 0, 0. What that implies is the corner of this cell is 0 and then x, which x is the cell size. I'll write that right here. X is cell size. The corner of this cell is 0, comma 2x. Do you see why? Does that make a little more sense now?
So are you talking about, what are you talking about, the left corner or the right corner of this square?
Yeah, it really doesn't matter, but as long as I'm always talking about the same corner. But in ArcGIS, the convention is the lower left corner. But even if I was talking about the upper right corner, it wouldn't matter, as long as I'm always talking about the upper right corner of all the cells. I only need to specify one corner.
So that whole square is 0, 0. The next one is 0, 1, 0, 2.
No, the values could be whatever. They could be 44, 55, 87. I'm talking about the geographic location of that cell.
The XY point.
Yeah.
Okay.
So the lower left here is what? The lower left corner of this cell right here is what value?
Y, comma 0.
If x, oh yeah, okay. So yeah, y comma 0. I see where you're going. Ashley, you're saying that y is the cell size in the y direction, right?
Yeah.
Yeah. Okay. So yes, that's true. So this would be 2y comma 0 for this cell right here, 2y comma 0. So the coordinate of this cell would be x times 2, 3, 4, 5, 6, 7, and y times 7. So it would be 7y comma 7x, or 7y comma 7x, because I think there's 7.
7, 7. Okay. So we're just talking about the geolocation.
Yes.
For these cells. Oh, okay. We're not talking about numbers in the cells.
Right.
Just location on the XY. Okay.
Exactly. All right. So that's what you need. That's why you need to specify the left corner, lower left corner, because it might not always be 0, 0. In fact, it rarely is. Okay. So we're specifying where it is in space. And then once we do that, we specify that, and we specify y is cell size in y. We've specified where all the cells need to go once we've specified these three values, the lower left corner and the x and the y cell size. That's why we need to specify those. Okay, so we specify those values. And then the next one here that we can specify is, do we want to assign any values in our array to be no data values? In other words, do we want them to be recorded in ArcGIS as no data? So the default is that none values will get turned into no data. In other words, they're null. So you can always take an array. Here's, my array. I could take the I could take 2 comma 2 and set that equal to none. Arguments must be a string. How's that? Let's print my array real quick. Oops. Print my array. There we go. My array. I might not be able to make it because everything has to be of the same type. But let's just say I made it -1. Now I could print my array. And then when I actually turn this into a raster, I could tell it -1 needs to equal no data. Okay. If I wanted to make that no data, we could try that. We'll try to do that in a second. And then we're not going to do this today, but we could create what's called a multi-dimensional raster data set using multi-dimensional arrays. But right now we're going to stick with 2-dimensional arrays. Most rasters are 2 dimensions, but occasionally we could deal with a multi-dimensional. So we're going to leave this alone for now. Okay, we're just going to...
I have a quick question.
Yeah.
You said that the first dimension of an array is the shape. What is the second one?
The first...
Is that or have we not covered it yet?
Well, the first thing that we feed it is the corner. Sorry, what? Repeat your question.
I was just for my note's sake, you said that the first dimension of an array is the actual shape. So whether it's 5 by 5 or 7 by 7, and so what is the second dimension?
I don't know. That's not right. So either I said it wrong or something happened in the translation. But it's one of the attributes of an array is its shape, and so we can modify the shape of an array by just telling it it's a different shape. It's an attribute of the shape. I mean, sorry, the shape is an attribute of an array. So we can reshape an array by just telling it, hey, your shape is now 5 by 5. We can also actually get the shape of an array by, I think it's, look at the syntax, array shape. I think, yeah, it's just called shape. It's a function called shape. So we can take an array and print its shape. Oh, print, because it is just an attribute of it. I didn't need to look that up. So now if we run...
would be an X and a Y then, not the shape.
Well, at the beginning, the dimension is just 25. So what the shape is, it tells you how many rows, it tells you how many elements are in each row and column. We could make, as long as we keep the same number of elements, we could reshape it to however many dimensions we want. Let me see if we could, is there an even way we could divide that into rows, columns, and time? Let's see, 5, 5. Is there any 3 numbers that will multiply together to equal 25?
1, to add 1 in there too? The number 1?
Let's see what that'll do. Yeah, okay, so what we did was we reshaped the array to have rows, columns, and something else, but we only had 2 of them. Okay. Let's change this to 30, and then we could change this to if we did 3, 5, and 2. There we go. That'll make a little bit more sense. So now we'll print that. So now it's a 3-dimensional array. This is the first dimension. This is the second. This is the second. This is the second dimension. The third, not dimension. So we've got rows, columns, and let's call this time. So this is the first time, the second time, and the third time. And then these are the rows and columns in that time. That's if we wanted to. If we wanted to give it a variable, we'd have rows, columns. I mean, if we want to give it a name, it doesn't necessarily mean time. It has whatever meaning we want to attach to it. It could be rows, columns, and then it could be band number. Like these could be the brightness values in the red band. These could be the brightness values in the blue band. These could be the brightness values in the
So it's a way of breaking up a set of numbers to be able to evaluate them. I don't know this.
Yeah, the point is that when we create an array, it's usually a single dimension. So now it's got 100 values in it. So we could do 25, 2, which should give us 100, right? 20 times 5 times 2.
That's 200. No, 2 would be the
20, yeah, no, 20 times, sorry, no, that wouldn't work. 5 times 5 would be 25 times 4. Yeah, okay.
That's 4, correct. So you'll have 4 of those.
Well, actually, I have 5. 1, 2, 3, 4, 5. So the 4 comes into place where you only have 4. So it starts with 4 columns.
Okay.
So we read this. The way we would read this back is that we would have the first one is that other variable. Then this is rows and columns. So whatever 5 represents, that first variable is the
Is the third.
yeah.
So it's 5 sets of 4s and 5s. X, Y, Z.
Yeah, it's 5 sets of 5s and 4s. Yep.
So it's 4 rows. Okay.
It's 4. No, it's 4 columns. So the last 2 are always going to be rows and columns.
So 5 rows and 4 columns.
5 rows, 4 columns, and then 5. So 4 columns, 5 rows, and 5, whatever we want to label it as. It's another dimension. 5 of whatever other dimension we have that we're going to deal with.
Is it anyway, you don't go beyond 3 dimensions, right? It wouldn't make sense.
Well, in most GIS applications, it wouldn't make sense. But there are other applications where it would, and you could do that. So we could go 500 here, and then add another 5 to the beginning, or maybe even 300 and add a 3 to the beginning, and run it, and it would still work. But all these numbers multiplied together need to add up to the size of the original. So here,
Would that be 4-dimensional? Would that be 4-dimensional, what you just did?
yes, it's a 4-dimensional array.
Wow.
So that could be used in time, correct? Like if you're trying to do time.
Yeah, so in this case, we could be this could represent time, this could represent band number, this could represent rows and columns.
Okay. All right.
Yep. So you can have pretty complicated ones, but for right now we're going to stick to 2-dimensional. Maybe we'll show an example where we have more than 2-dimensional. All right, so we're going to take our point and we're going to put our point at 50, 50. Okay, and then we're going to create a raster at 50, 50, where the raster is the result of this of this array. So the array is going to be created from the raster. the lower left corner is going to be the point. Now we don't actually have to put this here, but ArcGIS allows us to do that, and in their help they show it. But Python, you can just put it in the right order, or you can put the names of the variables. So you can do that. Also, if your X and Y cell sizes are the same, you don't have to specify both. It will imply, if you only put one, it'll imply that they're both the same. So you could, in other words, this is also a valid statement, just doing this, because you can pass it by. So to go back to here, the first is the array, the second is the lower left corner, the third is the cell size. We don't need to specify Y cell size unless it's different. All right, so then what it's going to do is take that raster, what this does is it returns a raster that is the same as the rasters we've been dealing with before. It exists in the computer's memory, but we don't know where it exists. And if we want to actually get it, we have to save it into a certain location. So here, I'm going to save it into my temp file. In fact, I think I'm going to save it. I'm going to save it into C temp. I was saving it into here, but I'm going to go into this week's lab and save it right here. I'm going to change the path that I save it to. I'm going to put the R in front of it. Okay. So now it's going to put it in there. So now I'm going to run this. File, save. And then I'm going to run this guy. And when I run it, and it completes, there's the raster that it created. There's the array that it just created. So we've got 97 in the upper left corner, and 22 in the lower right corner, and 5 in the lower left corner. So remember these values, right? Look at on disk. Now I have that raster saved to disk. Okay. So now I'm going to go into ArcGIS, and I'm going to add that. I'm going to add that data that I just created.
Once you pull that up, can you show your code for a second?
Oh yeah, sure. C temp, SPA, week 9. There's my random raster right there. Okay, I'm going to zoom to it.
So rest is just squares.
Yep. Well, this one is squares. If I gave it a different value for the Y, they would be rectangles.
Oh, okay.
But yeah, so
Basically made like different colors so you can tell them it's what.
by default, if there are less than, I think it's 100 values, by default it displays it using unique values. But I could change the symbology to stretch or to discrete. I can change the symbology, but yeah. Okay, so how can I verify if the numbers are the same?
I guess click each one.
Yeah, so I'm going to click this guy right here, and the value is 97. Click this guy down here, the value is 5. If I click this guy right here, the value is 22. And those are the same values that are down here, 97, 5, 22. And here's the code.
So you took out the left corner, lower left corner equals point, just kept point. It didn't matter.
Yeah, I was just showing that either one of those would work. Like
Okay.
Python.
Put the number 10 instead of X cell size is 10.
Yeah, either one will be the same. So Python, it didn't used to. So you'll see this is kind of like an older way to do it, but Python now will allow you to specify. If you know the name of the variable, you could specify it like that. And the advantage to that is that if you do this, you don't have to put them in the same order. The disadvantage is that you have to remember, and it's more verbose. So what you could do, what I'm trying to say is what you could do is, like I have it like this, and you could switch the order of these two. So I could put this over here, and it would still run, even though they're not in the right order. I personally prefer to not do that. I personally prefer to do it like this. But the original one I just copied right out of the help. You can see right here they use that notation. See, x cell size equal to 1. In fact, they used that random integer. They reshaped it to 50/50. Okay. Yeah, so look, this is also interesting looking at the help. If you do have a multi-band image, it will assume that it's band, rows, columns. Otherwise, they're just in rows and columns. So it assumes that they're bands first if you do that.
So what we was doing before was band, rows, and columns. You know, when we had all, the GHY, the first one was band, next one was row.
We could see if that works. I'm not positive that it will, but let's just try something. So we're going to call this my random raster 2. We'll change this to 100, and we'll do 5, 5, 4, right? And we'll run this guy. All right, so it looked like it ran. Let's see what it looks like in ArcGIS. So we're going to add I got to refresh here. We've got my random raster 2 now. If we click once inside of it, we do have 1, 2, 3, 4, 5 bands. So it will by default create a 5-band data set. So if we click on the upper left corner here, so we create a 5-band data set. So the values would be 1, 56, 30, 64. 1, 56, 64. 1, 56, 64. So yeah, it worked to do a multi-band raster like that.
Wait, you only have 3 bands? Did it make 4?
So ArcGIS and most GIS products, even remote sensing products, they'll only display to you 3 bands at a time. That's called a false color infrared. We could actually add all of the data. See here, if we have this as RGB, we get the red, green, and blue. We get band 1, band 2, band 3. But we have the option of showing band 4, band 5. We could see any of the bands in any combination, but we can only see 3 at a time. So it's putting band 1 in the red color gun, it's putting band 2 in the green color gun, and it's putting band 5 into the blue color gun. So something that appears green like this one right here, we click on it. See how the green value is much higher than the other 2 values? That's why it's green, because the green value is 83, whereas the red value is 13 and the blue value is 20. Would we expect in a blue pixel, the blue value is the highest, or in a red value, the red value is the highest. So this is the colors that you see are the mixing of those 3 bands, just like they would be with a remotely sensed data set.
So these are trying their best to be a true color image. If you had, 1, 2, and 3, it's making a true color image based on if those really were reds, greens, and blues.
Yeah, by default, if you add any multi-band image into ArcGIS, it will display it using RGB. But we could add just, like if we want to go in here, we could add just the first band. And then now that's just the first band. If we click on the values, we'll get just the first band. So that's a 1, that's a 21, 91, 1, 21, 91 are the values that I hit right there. All right, so what is the corner of this raster cell?
That's 0, 0. Well, no.
Is that what we said? Zoom out. See. That looks like it. That looks like it is, or at least. So let's look at the properties of this raster. So the rows and the columns, the number of bands, 1, the cell size, TIFF, spatial statistics, extent. Okay, the bottom left is 50-50, but in unknown coordinates. We don't know what those are. So that's why it puts it right there. So let's just, in order to like see relatively speaking, to see where this is, let's run it again and say that this will be 3. And instead of making it 50-50, we'll make it 80-80. So now we'll try to run this guy and see where it puts my raster 3. So it should be in which direction? Like if the corner of this is 0, 0, where should the next one be?
To the right and up.
Yeah, to the right and up. So add that other data set, my random raster 3, and it's to the right and up. So the corner of this one is 80-80 and the corner of this one is 50-50. Now, why is the corner of this one right here? Like it's exactly lined up, isn't it? With this cells in this one. Well, the corner of this one is 50-50. So the corner of this cell is, because the cell size is 10, the corner of this cell is 60-60, the corner of this cell is 70-70, and the corner of this cell is 80-80, which is the corner of this whole raster. Yeah.
Can you zoom back in?
Sure.
So that was like a little piece. What does that mean?
Which piece?
Okay, all right, go up with your mouse. Go a little bit, right there. Scroll down a little bit. That little yellow piece. What is that?
This yellow piece?
Yes.
This is the corner.
Scroll right there. See that little tiny piece that's right there? That's like a little strip. See what I'm talking about?
Color blending.
Uh,
I don't.
you see what I'm saying?
else?
Right here.
Okay,
It's like a little strip. Right.
yellow
It's
strip.
a little tiny strip right there.
Oh yeah, that's just the
What does that mean?
That's just the interface. Like I don't know whether that's our eyes trying to blend those two colors, or whether that's the on the screen.
Well, if you stay right where I'm at, you actually can see it.
If you change the symbology of that black and white to another color, it will be a great thing.
So you can see it a lot better. See it?
Yeah, the interface. Yeah, I'm not sure if that's an optical illusion or what, but it's just the boundary. So if we like Elvis was saying, if we change this to black and white, do you still see a boundary?
No, well, kind of a little bit, yeah.
Yeah. Well.
Over any other squares, but it's got a little bit.
Right. Yeah.
Right
So
on the gray strip.
there is a principle called simultaneous contrast, which means that looking at two different things that are two different colors, we'll see the boundary differently depending on what those two different colors are. So, you know, our eyes, I don't want to say play tricks on us, but our eyes will, and each of us see things differently on top of that. But yeah, anyway, that's not a real thing. This cell has a value, that cell has a value, that cell has a
So
value.
it's basically.
Yeah. All right. Yeah, go ahead. Oh, sorry. Yeah. What's that?
You want to take a break?
You want me to take a break right now?
You can go on if you want to. I was going to take a break.
You're going to take a break. No, I'll take a break too. Let's come back at 2 o'clock. We'll take a break. All right. Yeah, we'll take a break. I was almost done with this example, but we'll take a break.
You said something.